Okay. So, now I consider a sequence which is right sided. That is, it starts at any n 1, okay, and any n 1 greater than or equal to 0 and goes up to infinity x of n. Okay. To start with n 1 greater than or equal to 0, then we will consider the case when it starts at a finite negative point and goes to the infinity, but that later. So, first is as before x z we will take from n 1 to infinity only, because values to the left of n 1, the sample values of x n are 0. So, those products are 0, no point in considering them. Then as before we take the mod and mod of a summation less than or equal to sum of mod, that continues mod of x n and mod of z by to the power minus n, which give rise to r to the power minus n. All right. Now, suppose this RHS means right hand side, this quantity is finite for some r. R is nothing but mod of z, magnitude part. Okay. Then, for some r equal to say suppose r naught. Okay. If you put r naught here in this summation is a finite. Then, for any r greater than r naught, what happens to the summation? It is r to the power minus n. Okay, in this summation you see r to the power r is greater than r naught, which means r to the power minus n is less than r naught to the power minus n. Okay. R is greater than r naught. So, r to the power minus n means what? 1 by r to the power n, that will be less than 1 by r 0 to the power n. Isn't it? Very simple. Suppose 4 is greater than 3. So, 1 by 4 less than 1 by 3, any positive power of 4, okay, because the powers are positive powers, small n starting from capital N 1 to infinity, all positive numbers. So, any positive power of 1 by r, that is 1 by 4 here, will be less than any same positive power of 1 by 3, that is 1 by r 0. Okay. This means actually 1 by r to the power n, n is positive, because the summation considers n in the positive zone, right. That means the summation is to consider any small nth entry, mod x n was present here also, but that time I assume that the summation is finite for r equal to r naught, that is, if we have r naught to the power minus n this is finite, this is what I have assumed that exists. Now, in this summation consider any sample nth, mod x n present here, mod x n present here, but that time I was multiplying by r 0 to the power minus n, and I am now multiplying by a smaller number r to the power minus n. So, in the previous summation, this positive number, this is mod x n multiplied by one positive number r 0 to the power minus n. Here again the same positive number mod x n multiplied by a smaller positive number r to the power minus n. You see r to the power minus n. So, obviously, this is lesser than this. So, this whole sum is less than this summation. So, if this summation is finite, this is also finite. This summation is less than this summation, because for mod x n common, r to the power minus n is a positive number less than r 0 to the power minus n, as you have seen here, because r is greater than r naught, I am taking r greater than n naught. So, r to the power minus n is less than r 0 to the power minus n, which means this will be finite. Therefore, it means what? If this converges for some z with magnitude r naught, then there is suppose this much is your r naught and this is a z, and this much is your r naught. You draw a circle through this of the radius r naught. Then for any z outside this circle, magnitude will be r, mod z r will be greater than r naught, right, for any z here, say, if it is z here now. Okay. So, this magnitude is r is greater than r naught. So, for that r, this summation is finite. If r is greater than r naught, this summation is finite. Okay. Therefore, if z is here, then for that z transform will exist, which means the entire region outside this circle up to infinity, entire z plane outside this circle will be a region of convergence. Now, I arbitrarily started saying that suppose this is finite, that is the z transform exists here for some r equal to r naught. Now, you start exploring, if I go below r naught, still does it converge? If yes, still I make it lesser. Finally, a point will come when I will be in the bordering point. If I make r naught lesser than this, then summation will not converge. So, I will stop here, and from previous discussion, the entire region outside this circle will be my region of convergence. So, if it is a purely right sided sequence starting from a index n 1, which is either 0 or positive, ROC is region of convergence, that is ROC is outside a circle up to infinity, no restriction, it can go up to z equal to infinity. Now, I make it more general, that suppose the sequence is right sided, but it starts at a finite negative value here, n 1, n 1 is a negative number, dot 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 dot, and then this, that is and then to the left all zeros. Then z transform as before, n will start at n 1 negative value up to infinity, and this summation I can write as a summation of two parts. One will go from n 1 the negative value up to minus 1 here, and other will go from n equal to 0 up to infinity, from here then here up to infinity. Then mod x z is mod, but mod of a summation is less than equal to summation of the mod. So, this is less than equal to summation of mod of this part is a finite duration sequence. We have already considered them from some negative index n 1 to another negative minus 1. Okay. So, this will always exist, this will always exist except for z equal to infinity, okay, because minus n and n is taking negative value. So, it will be plus n. Okay. So, when you write z equal to I mean basically if you break it further, it becomes mod of summation less than equal to summation of mod as purely as before, and summation of mod means product of the mod, a mod of the product, the same as product of two mod x n, and mod of z to the power minus 1 is giving rise to this, and on this side again mod of a summation less than equal to summation of mod, the summation of the product, mod on the product means product of the mods, but mod of z to the power minus n is r to the power minus n this. All right. This summation is always finite, we have seen, okay, finite duration, it is like a finite duration sequence from n 1 to minus 1, only those finite number of points in this summation, otherwise no point. So, this is will always exist for any r except for r equal to infinity, because n is taking negative values here. So, here it is positive. So, r infinity means it will diverge. So, this is converging everywhere except at r infinity, and this summation is for a sequence that starts at n equal to 0 up to infinity. So, it is a purely right sided sequence. So, its convergence will be outside a circle up to infinity. Okay. So, if I now for Z transform to exist, this should be positive, this should be finite, this should be finite, because this is a positive number, this is a positive number. So, they cannot cancel each other, both have to be finite. It is not that this is infinity, but one is plus, one is minus, infinity minus infinity 0, that does not happen. This is positive, this is positive, that is non negative, non negative. So, this must be finite, this must be finite, but this summation is finite means this is for a right hand sided sequence, because n is from 0 to infinity, that is this part, this sequence, left hand side zeros. So, we have already considered this case for this kind of Z transforms, that is right sided sequences. Z transform exists, the region of convergence is what? Outside a circle, okay, which we have like this, outside a circle up to infinity, and if this part is present, infinity is not allowed. So, overall, yes, outside a circle, but excluding z equal to infinity, r equal to infinity or z equal to infinity. In this case, if it starts at n 1 to the right of origin or at origin, not at negative index, then it converges outside circle, outside some circle goes up to infinity. Okay. This is for the right sided sequences. In a absolutely similar manner, we can consider a left sided sequence. Okay. That is, suppose to start with, I assume that I am starting at some index, say n 1, and then I am going, it is like this, and up to infinity, and then all zeros, and suppose n 1 is less than 0. In this case, Z transform n will be from n 1, which is a negative number, up to minus infinity. So, you take mod x z, mod of a summation less than equal to all those things, suppose RHS, that is this summation right hand side, is finite for some r equal to r naught. Remember, here n has a minus sign, but n is taking negative indices, capital N 1 is negative, and further we go to the negative. So, negative, negative, positive. So, basically positive powers of r are coming. Okay. Now, if this is true, that means I am assuming n equal to this to minus infinity mod x n r naught to the power minus n, if I replace r equal to r naught, this is finite. Now, if I take any r less than r naught, then how about this summation? Everything else is same, mod x n, n 1 to capital N 1 to minus infinity, same. But here it was r 0 to the power n, r to the power minus n. You see, minus n is positive, because n is taking negative number. So, r 0 to the power some positive power, r to the power the same positive power. Therefore, if r is less than r naught, then this is also less than this, r to the power minus n for negative n, this also less than, because if n is negative means it is positive now, minus minus plus, minus minus plus. So, if r is less than r naught means r to the power minus n for negative n will be less than r naught to the power minus n. So, mod x n here multiplied by r naught to the power minus n, and here multiplied by a number r to the power minus n, but this is lesser than that. So, that means summation is lesser than this summation. So, if this is finite, this is also finite. Okay. So, this means if this converges for any r naught, you draw a circle in the z plane of the same radius r naught. So, for any z on this circle, you have got magnitude r naught, and this is satisfied means z transform is existing on this circle. In that case, you consider any point z inside, say here, the corresponding r is the magnitude that is less than r naught. So, if z is here, for that z, obviously Z transform will exist, because this will be finite, because this is finite, R is less than R naught, this much is R, this much is R naught. Now, I took R naught arbitrarily. Now, I start expanding R naught. If I expand the circle, make it bigger, finally, a point will come that I cannot expand anymore. If I expand anymore, it will not converge. So, suppose that is the limiting case. Okay. So, ROC will be full region inside the circle, outside it will diverge. Okay. Origin is included, because I am considering negative power indices. So, positive powers of R. So, if R is 0, does not matter, 0 to the power positive power, no problem. Now, I will consider a sequence which will be left sided, okay, but we will start at a positive index, that is and then 0, 0, 0, 0. In this case, this summation you write as a summation of two component, n equal to n 1 to 0, this n 1, n 1 minus 1 up to 0. You can either take up to 0 or maybe 1. Or maybe 0, okay, 0 will be better, n 1 to 0, and then n from minus 1 to minus infinity. So, therefore, mod of x z will be this, which is less than equal to mod of this plus mod of this again less than equal to mod of a summation less than equal to summation of mod of this and r to the power minus n, and again here the same way. So, if this is finite, this is finite, this is finite, none of them should be infinity, and they are both positive. So, it cannot happen that this is infinity, this is infinity, but infinity minus infinity is 0. Okay, that cannot happen, the positive thing. Okay, there is a positive sign here, right. It cannot be that okay, this is positive plus infinity, this is minus infinity, and they cancel, it is not possible. Now, this is the finite sequence, finite sum n 1 to 0. It is like the Z transform, it is like the case of Z transform of a sequence, that is from 0 to n 1, 0 to n 1. So, you have seen Z transform, that is this summation will be always existing, always finite, but since small n is taking positive values here, 0 or positive, 0, 1, 2 up to positive, there will be negative powers of n, okay, negative powers of r. Therefore, r equal to 0 will be ruled out. So, this is everywhere, convert this everywhere except at r equal to 0. And this one is a purely left sided sequence from n equal to minus 1 to minus infinity, that is this part, and for this region of convergence is inside some circle. So, together this means it will be inside some circle ROC, but this is excluded, otherwise this whole area, but this is excluded. And lastly, the more important case of a general sequence, that is both sided sequence. For a both sided sequence, it is from minus infinity to infinity. Here x z okay. And this summation will break into two parts, n equal to minus 1 to minus infinity. So, mod x z is this, which is less than equal to mod of this plus mod of this, and mod of this is further less than equal to r to the power minus n same. Again this must be finite, this must be finite, because both are positive and there is a plus sign. So, if both are positive, then only right hand side is less than finite, and therefore, left hand side is guaranteed to be finite. Now, this is corresponding to a purely right sided sequence from 0 to infinity. So, its region of convergence is outside a circle up to infinity, and this is a purely left sided sequence from minus 1 to minus infinity. Its region of convergence is inside a circle up to origin. Now, suppose the two circles are such that there is an overlapping region, that is, in one case outside this circle, that is from this up to infinity, and in another case inside a circle, that is from this. Okay. Then we have to see the overlap, this part. This will be the ROC, because here both will exist. But if the two circles are such that there is no overlap, one is, I mean, from here it is inside a circle, suppose here, and from here it is outside a circle, then there is no overlap between the two shaded regions. In that case, there is no ROC, the sequence, so Z transform does not exist. Okay. See, region of convergence is very important, because you see, I can give you the same sequence. I mean, you can have same Z transform expression. Suppose I give you a to the power n u n. Okay. What is the Z transform and ROC? Okay. If this is x n, it will give rise to what? X z summation. Since u n is present, it will be from 0 to infinity, and therefore, a to the power a z to the power minus n. Okay. That means, a to the power 0, z to the power 0 1, then a by z, a square by z square, dot 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 dot. This infinite sum will converge if this is less than 1, we all know, and it will then converge to 1 by 1 minus a by z. This is from basic algebra. We write it as 1 minus a z inverse. This is a right hand sequence. Its region of convergence should be outside a circle, and what does this give? Mod a by z is less than 1. You know that mod of two complex numbers z 1 by z 2 is same as mod z 1 by mod z 2. If you do not remember, if you do not understand, remember z 1, if you write as r 1 e to the power j theta 1, this you write as r 2 e to the power j theta 2. So, division base r 1 by r 2 into e to the power j theta 1 minus theta 2. Mod of that will be r 1 by r 2 into mod of e to the power j theta 1 minus theta 2, but e to the power j theta 1 minus theta 2 has mod 1. So, it will be r 1 by r 2, and r 1 is this, r 2 is this. Okay. Now, mod of a by z less than 1 means mod of a less than mod of z, which means ROC is what? There is a circle of radius a and mod z greater than mod a. So, radius is mod a. So, a whole region outside this, okay, where mod z greater than mod a. So, any z here means this mod will be greater than mod a, that is the ROC. I consider, and in the ROC the Z transform is this. I consider a different sequence now, a to the power minus n u minus n minus 1. What is this sequence? U minus n minus 1. So, at n equal to minus 1, it will be minus minus plus. So, plus 1 minus 1 0. Okay. So, it is the sequence is like this. At n equal to 0, it is u minus 1, value is 0. So, 0. At n equal to 2, n equal to 1, minus 1 minus 1, u minus 2. Sorry, at n equal to, n equal to 1, u minus 2, u minus 2 is 0. N equal to 2, u minus 3, 0. This at n equal to minus 1, minus minus plus, 1 minus 1, 0, u 0 is 1, a to the power plus 1, because n is minus 1. So, you have got a, that then at there is a minus 1, then at minus 2 a to the power 2 a square, okay, because minus 2 means plus 2 minus 1, that is plus 1, u plus 1 is 1, and this way this side will be a to the power 3 dot 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 dot. If I take the Z transform of that, this sequence, summation will be from minus infinity or minus 1 to minus infinity a to the power minus n, that is n minus 1 means a to the power plus 1, n minus 2 means a to the power plus 2. Okay. Z to the power minus n, all right. And what will be the summation? It is like 1 plus one by a z plus 1 by a z square and dot 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 dot. See, mod of this is less than 1, then you convert this, but mod of this less than 1 means mod of 1 divided by mod of z, a z, and mod of a z is mod of a into mod of z. So, if you simplify, it will be this. Okay. I changed the problem a little to make it more convenient. I just make a little change here. This part is fine, this is also fine, but and then it will give rise to, if this happens, 1 by 1 minus 1 by a z. Okay, this is fine, but I will just change the problem a little bit. Instead of a to the power minus n u minus n minus 1, suppose I consider a to the power n. In that case, the sequence will be from here only, but n is minus 1. So, it will be a to the power minus 1 instead of a, then a to the power minus 2 and dot 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 dot. In this case, Z transform will be the same way. A to the power n okay. That means a to the power minus 1. So, z by a, then z square by, here there was a mistake I was making, sorry, here n was negative, right. So, it cannot be 1 by a z, a to the power it was a to the power plus 1, because n is minus 1. So, a to the power plus 1, z to the power plus 1. So, it will be 1 plus a z, then a z square, a z cube dot 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 dot. So, this is not thing, mod a z should be less than 1, which means mod z should be greater than 1 by mod a. Okay, mod a z should be less than 1, then only it converges, and this will be 1 by 1 minus this one. I am sorry, this was because n is taking negative value. So, a to the power minus minus 1, so to the power 1, n is minus 1, z to the power minus minus 1. So, a z plus a z square a z cube dot 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 dot. So, you take a z common. So, there will be a z here also. Okay. All right. So, there is a small mistake. Here it is z by a plus z square by a square dot 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 dot. See, mod z by a less than 1, which means mod z less than mod a, then this converges, and if you take z by a common, it will be z by a divided by 1 minus z by a to common, so it is 1 plus z by a plus z square by a square dot dot dot, and under this condition it will be this. And if you divide numerator denominator by this quantity, it will be 1 by 1 minus, sorry, 1 by a by z, that is a z inverse minus 1. Okay. So, if I further make a change, if I put a minus here, minus, there is, if the sequence is minus a to the power n u minus a minus 1. So, the minus sign, there is a minus sign here, equal to, there will be a minus sign here, and if you put the minus sign inside, it will be 1 by same expression as this. So, same one, I mean two different sequences. See, that was a right sided sequence. Okay, that was a right sided sequence a to the power n u n has got this expression, and now this has got a left sided sequence, this one, that was this is this. Both of them have this form, same Z transform, but what does it differ? In one case it was ROC was mod Z greater than mod A, that is, you draw a circle of radius mod A is greater than that, and in this case it is less than mod A, that is inside this. Okay. So, that is the difference. You see, you can have for two different sequences, you can still have the same Z transform expression, but where they will differ is in terms of ROCs. So, that is all for today. We will continue from here in the next class. Thank you very much.